Hello and welcome to the European Space Operations Centre here in Darmstadt in Germany. I'm Katie Haswell and I'm going to be taking you through today's launch of the first pair of cluster satellites with the help of some ground control staff, some scientists and some engineers. We'll also be telling you something about the mission itself and why it's such an important component of the International Solar Terrestrial Science Programme, the ISTP. Now, to begin with, let's take a look at the satellites themselves. So they are sitting on top of the Sojuz rocket on pad 6 at the Baikonur Cosmodrome. This is an extremely special mission. It's the first time that ESA has worked with the Russians and launched its satellites on Sojuz, so it's an exceptionally exciting day for everybody. Now, we have several experts with us to take us through the launch. First of all, to keep us up to date with what's happening with the launch vehicle itself is Vladimir Kotin. Vladimir is Cluster Technical Manager for Starsem, and that's the company responsible for the Sojuz frigate rocket. Vladimir, what's your status?
Hello. So as you can see from the screen, Sojuz launcher is on the launch pad. It's fueled completely, and the servicing towers are retracted, and now launcher is preparing to flight. You can see the clouds. It's vapors of the liquid oxygen, which is a component of the fuel, and external temperature is 27 degrees, and in the fuel tanks is of course much less. And we have the remaining part, which is the mast, which delivers the electricity and signal to the frigate control system.
Vladimir, thank you very much. I'm sorry, because we're going to move on quickly to Manfred Warhout, who's here at ESOC. Manfred, what's your status?
Yeah, hi Katie, this is Manfred Warhout from the main control room here in ESOC, and we are green. I think all panels, if I turn around, show green for the ground segment and the team, and we are looking forward for this launch. I'm here also in contact with the bunker in Baikonur in the launch pad and maintain this backup voice connection for the coming minutes.
Thank you very much indeed, Manfred. And here in the studio we have Howard Nye, who's the former ground segment manager, who's going to help us through events. Thank you very much indeed, Howard, for joining us. Well, we'll be telling you more about Cluster's mission and how the satellites were built later in the programme, but it's important to remember that even once you've actually built your satellites, there's still a lot of work to be done getting them into the air. And for the first time, the European Space Agency has been doing that work at Baikonur, the Russian cosmodrome in Kazakhstan. There we have it. Now let's take a look at today's Sojuz frigate launch vehicle, which is standing on the pad at Baikonur. There it is. Vladimir, can you describe what we're looking at?
So now we can see on the screen the upper part of the launcher, which is nose fairing, and the third stage at the bottom. At the left you can see the mast, which is connected to the interstage section here. And soon this mast will be retracted, and the only link with the launcher will be through the bottom part of the launcher. And you can see the fairing and the cluster logo on this fairing. And under this fairing there is the third stage and the cluster spacecraft. And we have now readiness 10 minutes before launch. Everything is okay. And we are waiting for the events.
What stage are we at, Vladimir, in the preparations?
So this is the final stage of the preparation. Launcher has been tested, frigate has been tested, and spacecraft were tested. We have green light up to now, and if no red line will appear, it will proceed automatically up to the command of K on start, which is ключ на старт in Russian, when the person switch on special K and authorized to proceed with automatic launcher preparation. After this, the valves will be closed, and you will not see this cloud of the vapors, because the pressure will start to increase in the fuel tanks. And at the end, we will have start command and ignition, which will last a long time. It will be 20 seconds. Launcher will be burning but not flying. And during this time, all the engines will be verified with several stages. And finally, after the OK for all engines, we can see the takeoff.
Okay, thank you, Vladimir. So far, so good. We're about 13 seconds to launch. Cluster is a particularly special mission, of course, because it's the first time that ESA has sent 4 satellites up to work together as a team. But what exactly will that team do?
Unseen by human eyes, but very plain to the electronic eyes in satellites, swarms of atomic particles battle with magnetic fields in space far above our heads. The latest scientific project of the European Space Agency uses a quartet of satellites to probe the invisible storms that jolt our planet. The Cluster mission. The Sun rules the solar system, and the Earth, circling around the Sun, swims in its electric sea. A solar wind of charged particles fills a huge bag in space, and we're deep inside it. The beautiful auroras of the Arctic sky are caused by the solar wind. But the same space storms are a threat to our electrical, electronic, and satellite systems. So it's an urgent task to find out what's going on. A bubble made by the Earth's magnetic field, called the magnetosphere, shields us from the direct effects of the electric sea. But the solar wind probes those defenses, and some particles break in. In these inlets and all around the planet, great mysteries remain. To solve them, scientists explore the electric sea using satellites with clever instruments. Each of ESA's cluster satellites is a highly equipped laboratory. It measures the electric and magnetic fields, senses peculiar electric and magnetic waves, samples the electrons and charged atoms that come its way. And by doing that with 4 satellites together, Cluster builds up a 3-dimensional picture of the electric sea. That's what makes the mission unique. And the 4 satellites will visit each of the magnetosphere's trouble spots in turn, on an orbit reaching nearly 120,000 kilometers from the Earth. Further out in space, ESA's SOHO spacecraft gives early warning of space storms. SOHO and Cluster are sister projects of international cooperation between the European Space Agency and NASA. And on the ground, world-encircling networks of space weather stations collaborate with Cluster. Meanwhile, the auroras of the northern lights taunt the scientists. As if in a giant TV set overhead, atomic particles paint ever-changing pictures on the air. They're steered by storms farther out in the electric sea. Cluster's task is to make sense of it all. Because until we know how the sun affects the weather in space, and perhaps the ordinary weather too, how can we really understand the Earth's environment?
Now, of course, just one of the complexities of the cluster mission is controlling 4 spacecraft. They fly in a very precise pattern, which can obviously vary considerably over the year. So you need to have some way of identifying each one of the satellites. Now, you could do it with numbers, but that's not very friendly. So ESA decided to have a competition to find names for each one of the 4 spacecraft. The rules were that you come up with 4 related names and then give reasons for why they're suitable. So let's take a look at some of the results.
My name is Andreas Rosenstingel and I come from Vienna in Austria. My suggested names are Vento, Nubo, Fulmo and Pluvo.
My name is Mia Stampe. I'm from Copenhagen, Denmark. I suggested the names Occidentalis, Orientalis, Australis and Borealis.
Hello, my name is Ola. I'm from Sweden. My entry is flute, violin, cello and piano.
I think the cluster satellites should be named for the 4 great solar festivals of the Celtic year: Imbolc, Beltane, Lunasa and Samhain.
I choose 4 birds: albatross, condor, royal eagle and seagull.
Well, now, those were just some of the 15 finalists, one from each of ESA member countries. And at this moment, they're actually watching our programme from ESA's establishments in France, Italy and the Netherlands. But we actually have 4 of the contestants here, 4 of the finalists here in Darmstadt. Now, I believe you're Raymond Cotton, is that correct? Yes. Do you want to stand up? Can you tell us what your names were?
Yes, it was Tango, Rumba, Salsa and Samba.
And why did you choose those?
Because I felt the satellites were dancing in formation, and it was international names, recognisable by all.
Lovely idea. And now you're Paola Benna, is that correct? Yes. Now, from Italy.
Yes.
What were your names?
My names are Urano, Gea, Chrono and Teti, and they are the names of the Titans.
Okay.
From ancient Greek mythology.
Well, it's going to be exciting to see who actually wins. Let's find out now what some of the other finalists had to think. Thank you.
Solea, Lunea, Ondea, Eolia.
Holland, Kin, Juno, Thun and Katun.
I am from Norway. My entry is Erythros, which means red, Chloros, green, Aureus, yellow, and Luteus.
Finland, Ukko, Kokko, Louhi, Ilmatar.
Adagio,
Largo,
Allegro, Vivace.
Well, of course, there are many finalists, but only one winner. And with me to announce that winner, I'm very proud to say we have the representative of the Director of Science, Martin Huber. Martin, fire away.
You expect me to open the envelope? It's already open. And the winner is Raymond Cotton from the United Kingdom.
Congratulations, Raymond. We'll announce the names in a second. Raymond? Right, we're going to announce the names here. They are...
The names are Tango, Rumba, Salsa, and Samba.
And would you like to present this to Raymond? And Raymond's family will be also travelling to Paris for a weekend. Thank you very much indeed. Congratulations. Now, Raymond's clearly made a mark on ESA's Cornerstone Science Programme, and his whole family, as I said, will be going off to France. But we've got just a little bit of fun here for you. Let's take a look at the dancing satellites. Well, now, each of those 4 cluster satellites are carrying 11 scientific instruments, and scientists have been working extremely hard to get them ready for today's launch. But the principal investigator for the electron drift instrument is here with us, Gert Pashman. Now, Gert, what is cluster all about?
Well, you heard from the video that the spacecraft are going to explore the magnetosphere, which is this space around us occupied by the Earth's magnetic field, deflecting the solar wind around it. And the main idea behind cluster is to explore these processes which nature has provided us a prototype of, processes which are of importance in the entire universe.
So why do we need 4 satellites?
Well, this roof, you imagine that the magnetosphere is providing this roof, protecting us against the rain from the solar wind. But we know from single spacecraft measurement that the roof is leaky. So imagine a single spacecraft flying through one of these holes in the roof. Well, it doesn't know how large the hole is. You need many spacecraft. You need 4 to actually probe the size of the hole in the roof in all directions. That is, in a nutshell, why we need 4 spacecraft.
Thank you very much indeed, Gert. That was an excellent explanation. Thank you very much. Well, it's now only a few minutes to 3.5 minutes to launch, and 2 of the 4 cluster spacecraft sitting waiting to go up from the Russian Cosmodrome in Baikonur. And here at ESOC in Germany, ground control staff have been monitoring progress from the control room, which is where Manfred Warhout is now. Manfred, can you tell us your status?
Yeah, hi, Katie. My status is my hands are getting wet now, yeah, because we are really getting closer. But the flight director has just a few minutes ago given the final go-ahead from the ground center to the launcher authorities, and this was also communicated then from the ground segment manager on site. So cluster is ready for launch, and we are standing by now.
Thank you very much indeed, Vladimir. Let's go, sorry, Manfred, let's go to Vladimir Kotin now. Vladimir, what's your status?
So now you can see that there are no clouds around the launcher because all the valves are closed and the pressure in the fuel tank start to be increased. So the unreversible sequence started, and at the end we will have a launcher start command and take off.
Okay, thanks very much. Now, Howard, perhaps you can just put this into context for us a little bit. What are we waiting for here? We're about just coming up to 2 minutes to launch.
Well, as Vladimir has just said, we are waiting for the final sequence of the launch vehicle to take place. This is an automated sequence. Once it starts, nothing is going to hold it. And of course, everyone is very tense here because we have to wait for the launch vehicle to do its good job before we can take control of the spacecraft.
It may be very tense, but nonetheless, everyone is extremely professional and has trained very well for this.
There's been a very long and interesting series of simulations to make sure that everyone in the control center here knows exactly what is happening, knows exactly what they have to do, and if anything unusual happens, they have trained in the steps that they have to take in order to get past any what we call anomalies.
Now, we're heading very, very quickly towards the moment which is known as the umbilical mast release. What are we looking at here? This is the fairing of the rocket.
That's right. The umbilical is if you like, the power line, which is the last connection between the controllers of the launch vehicle and the launch vehicle itself. And once this power line is released, we see this on the pictures in a few moments. That is the last time that the ground controllers have contact with the launch vehicle. Then it's running on its own, and it's going to take off at the time.
And we're now looking at 15 seconds to that umbilical mast release. So it's quite an exciting moment because we're very, very close to launch now. Right, I think we're going to go now to Vladimir Kotin to see what exactly is happening. Vladimir, can you keep us up to date, please?
So, as you can see, the umbilical link not disconnected, and we listened that the launch sequence interrupted. And the reason might be several reasons, because we have launcher readiness, payload readiness, frigate readiness, and in total, each of these components can send the red signal to stop the sequence.
Vladimir, can you just go back over now what those reasons might be?
The launch readiness is the combination of the readiness of all the launcher components. It's a launcher itself, it is a frigate upper stage, and it is the spacecraft, two spacecraft. And each of these components can generate a green light or red light. And in combination, we'll have a red light in case of each component has a red light. So now it was some reason probably to have a red light.
Okay, well, let's have a quick word now with Manfred, who is here at ESA in Germany. Manfred, what can you tell us?
Yeah, hello, Katie. As you might have heard, we have also from Vladimir gotten the confirmation that we have a sequence aboard. We are now in train to determine what the exact time was, and there's not very much to add, so we have to just stand by.
Manfred, what is the procedure at this point in circumstances like this?
The procedure would be that everybody looks into his books, into their books, in how far they could have been the cause of this hold, but as far as we can judge from our side, ground segment was green, spacecraft was green, payload was green, so we have really to wait now and be a bit patient to hear what our Russian colleagues are supposed to tell us. So don't be unfair at that point in time, and give our colleagues some time to see what happened, and then we should be able to come back to you.
All right, we're going to have another quick word with Vladimir now. Vladimir, does this mean that we can still launch today?
So normally we can launch only on next day, because the Earth is rotating, and when we launch later, we will have different orbit. So we have to wait 24 hours, exactly 24 hours, and try to repeat the launch tomorrow.
And did you have any information at the time of abort?
So not yet clear what was the reason for stop of the countdown, because it's done automatically, and they need some time to verify which system generated the signal.
Right, well, we're going to come back to you in a second, Vladimir. Thank you very much indeed. Well, Howard, this is quite dramatic. What is the significance?
This is something which can be expected in such a launch sequence. There's a very, very complicated sequence of activities which are going on automatically on the launch vehicle. At any one time, if any one of the little parameters which are being checked in this sequence is not giving the right value, then the sequence may stop. And this is most likely what we've had. And of course, we don't have any direct contact with the launch vehicle authorities. Therefore, we're not in a position to say what this particular problem was.
Is there any chance that it could be to do with the weather?
This is a question we should have to ask Vladimir.
We don't know yet. Well, we're clearly waiting for information here from various sources to see exactly what's going to be happening. In the meantime, if Vladimir, you have any more information to contribute here, perhaps you could let us know what you're getting, what information you're getting through.
So at least the weather is not the reason for the countdown stop, because it's 27 degrees centigrade temperature. This velocity of the speed is 6 meters on the ground level, and in the altitude of 12 kilometers, it's only 16 meters per second. So it's not a stopper for the launcher. So the reason is probably some technical reason, and we need just to have time to clarify everything and to be able to repeat the launch tomorrow at the same time.
Right. Thank you very much indeed, Vladimir. We'll keep coming back to you. We have with us now Mathieu Weiss. What can you tell us?
So, hello, I'm the sales director for Starsem, and I just had a connection with Baikonur. So I can tell you that I can confirm what Vladimir said, of course. We will now investigate what is happening, but we can be quite sure that there will be a report. So as you may know, the launch window for cluster was 4 minutes today. So as soon as these 4 minutes are gone, we will have probably to launch then tomorrow on approximately the same time. The launch window will again be a launch window of 4 minutes. So now the last information I get is that people are investigating in order to confirm me what will be the decision which will be taken between the authorities of ESA and the authorities of Storsem, knowing that Professor Bonnet and Jean-Yves Le Gall, the president of Storsem, are currently in Baikonur.
Right. Well, thank you very much indeed, Mathieu Weiss. So we are going to leave you now with some pictures and take a break and find out what's happening next. Thank you very much.